This is Teacher Claire. Today we're going to talk about the computer system servicing in grade 10. But before that, let's recall our past lesson. Can you still remember our past lesson? Yes, you are right. This is all about procedures in using computer system configuration tools, correct? And now, can you name all those procedures? Very good. First is accessing and using Microsoft System configuration. Second, assessing and using Rich Edit. Then, assessing and using DirectX diagnostic. So what are the procedures of those? So in assessing and using Microsoft System configuration, first procedure is you have to click on Start button. Second, in the search box, type Run. And then, in the Run window, type msconfig and press Enter. How about assessing and using Rich Edit? First is, you have to click on Start button. Then, in the search box or Run window, type the following, Rich Edit, and then press Enter. The third is accessing and using DirectX diagnostic. So to run the Direct Diagnostic tool, first is you have to click on Start button, type Run on the search box. Second, on the Run window, type in DXDiag and click OK or press Enter. Then the last one is you have to, next you will see a new window with various tabs. I have a problem a while back. Can anyone help me fix the problem? No signal. What shall I do? I'll use an ordinary cable wire. Let's see if it works. But still, it doesn't work well. Do you want to help me solve it? That's why today we're going to talk about Lesson 2, Networking Devices, Media and Connector, specifically common network cables. Once again, I am your teacher in Computer System Servicing 10, Teacher Claire in Ozamis City National High School. Are you now ready to listen? Okay, so we will start. So what are the common network cables? And how are they look like? So we have here twisted pair, coaxial cable, and the fiber optic cable. What is twisted pair? So it is a type of copper cabling that is used for telephone communications and most Ethernet networks. And it's also a pair of wires forms a circuit that transmit data. See the illustration. So we have here UTP cable and STP cable. Furthermore, we're gonna talk about Ethernet networks cables that are used in local area networks, and I'm referring to twisted pair cables. These are the Ethernet cables that you'll find as you connect to your computer to your router or modem so you can have an internet access. One end cable plugs into your computer network interface card and the other end plugs into the network port of your router, switch, or modem, depending upon what you're using. Ethernet twisted pair cable come in different types. The first type is unshielded twisted pair, which is by far the most common type of cable that is used today. Unshielded twisted pair consists of 4 pairs of color-coded wires twisted around each other. The wires are twisted to prevent electromagnetic interference or crosstalk. This type of network cables is what most people use in their home or business. And the second type is shielded twisted pair. Shielded twisted pair is very similar to unshielded twisted pair, except that it has foil shield that covers the wire, The foil shield added a layer to protection against electromagnetic interference leaking into and out of the cables. This type of cable is mainly used for industrial purposes and not so much in a home or businesses. So those are two basic types of twisted pair cables, the UTP and the STP cable. What is UTP? It is unshielded twisted pair. So it is a cable that has 2 or 4 pairs of wires. Then this type of cable relies solely on the cancellation effect produced by the twisted wire pairs that limit signal degradation caused by electromagnetic interface or the EMI and radio frequency interference or the RFI. How about STP cable? So STP cable or shielded twisted pair, each pair of wire is wrapped in metallic foil to better shield the wires from noise. It has 4 pairs of wires are then wrapped in an overall metallic braid or foil, and it reduces electrical noise from within the cable. Category rating. UTP comes in several categories that are based in 2 factors. So these factors are the number of wires in the cable and the number of twists in those wires. Now, in addition to twisted pair cables, we also have to talk about the categories of twisted pair cables. And these categories are called Cat3, Cat5, Cat6, and Cat7. The difference between this is the maximum speed they can handle without having any crosstalk or interference. The numbers represent the tightness of the twist that are applied to the wires. As you can see in the illustration of the categories and speed of the different twisted pair cables, the speed ranges from the lowest category, which is Cat3 at 10 megabits per second, all the way up to Cat6A and Cat7, which has speeds of 10 gigabits per second. Now, most networks today use at least Cat5e in their networks because most networks would be running at least a gigabit speeds. So Cat3 and Cat5 are slower than gigabit and are pretty much obsolete today. But of course, if you're running a network that can handle 10 gigabit speed, you have to use Cat6A or Cat7 on your network. But even if you have an older network that's running slower speeds, you can still use Cat7 because it is backward compatible. Cat7 is actually a shielded twisted pair version of Cat6A. And finally, the latest version is Cat8. Cat8 is the ultimate copper cable. It's a shielded twisted pair cable which has a delivery speed of 40 gigabits per second and up to a distance of 30 meters, which is 4 times faster than Cat6A or Cat7. How about coaxial cable? It is a copper cord cable surrounded by a heavy shielding and is used to connect the computers to the rest of the network. So see the illustrations. These are the example of the coaxial cables. Furthermore, you will be introduced to coaxial cables and their uses. Coaxial cables had a wire center surrounded by an insulating material. The insulation is surrounded by a braided metal shield, which in turn is surrounded by a protected jacket. Because the center wire or conductor and middle shield share the same axis or center wire, they're called coaxial. They all share a common axis. This type of cable is more commonly referred to a shorter name coax. The center wire is electrical conductor that transmits computer data. The braided metal shield wire prevents electromagnetic waves such as the noise generated by light, fans, copy machines, and other devices that cutting across the center conductor and inducing unwanted voltages that may corrupt the data. The shield may be electrically connected to the ground. If so, the noise is shorted to the ground before it reaches the conductor wire. Some coax cables are used for computer networking applications, coaxial cables are identified by a two-letter prefix, RJ followed by a number. Then, for example, is RJ8. The number represents a rating developed by a US military to indicate different coax types. The three types of cables used for networking applications are RJ8, RJ62, and RJ58. Each one has specific characteristics, including the ohms ratings. The RJ62 rated at 75 ohms is similar to the cables used for television installation, which uses RJ6 as its identifier. Today, RJ62 cables are rarely used in networking applications because their primary use was in a network technology called ArcNet, which is basically obsolete. Another way of identifying cables is to use a code such as 10^2 or 10^5, which is developed by an IEEE 802.3 code. For example, an RJ8 could use to support 10^5 or RJ58 cable could be used to support 10^2. It should be noted that 10^5 has been much less expensive and more convenient alternative, which include 10^2 based on the thinner coaxial cable. Ethernet over twisted pair, which can support specifications such as 10^T and its successors 100^TX and 1000^T. Ethernet over twisted pair cables have for the most partly placed coaxial cables. The cable's code provides three types of information concerning speed, signal type, and distance. Let's use 10^5 as an example. Speed, the number 10 in a code, refers how fast it can be transmitted over the cable. In this example, 10 means 10 megabits per second. Signal type, the word base, in the code, refers to how many signal can be sent over the cable at any given moment. Baseband cables transmit one signal at a time. Broadband cables allow several signals to be transmitted simultaneously. Distance is a number 5 in a code, refers to the recommended maximum length to prevent any signal loss. In this example, 5 indicates the cable should no longer than 500 meters. Once commonly used for 10 megabits Ethernet, the RJ8 is a thick coaxial cable. For this reason, it's often referred to thicknet. The cable's IEEE 80.2 is 10^5, which means its maximum speed reading is 10 megabits per second. It's designed to pass base signals over a maximum distance of 500 meters. The RJ8 cable can often be identified by its yellow color. During installation, no devices must be connected only at the cable's black bands, which is based to 2.5 meters apart. The maximum number of nodes on the 500-meter thick net cable is 100. The two types of connections that are made between a node device and a cable are intrusive and non-intrusive. For intrusive connections, the RJ8 nodes don't connect directly to the cable's conducted wire. Instead, the AUI connectors, which are 15-pin, go between a terminal box and a computer. An intrusive connection doesn't require breaking the main cable. Instead, a tap pen in the end of the cable going to the computer is used to pierce a hole in the coax. This hole is used to make the electrical connection with the main cable. In the past, the coaxial cable most often used for Ethernet applications was the RJ58. Because its diameter is smaller than the RJ8 cable, is referred to thin net. This cable, a IEEE 802.3 code, is 10^2, which means that the maximum speed reading is 10 megabits per second. It's designed to pass baseband signal over a maximum distance of 185. The type of electrical cabler used at each end of RJ58 cable is the BNC or bayonet nail concealment connector. When connecting a node to a cable, a T connector communicates with BNC hardware. A BNC connector can't be directly connected to a node like the neck on the back of a computer. No more than 30 nodes can be connected to the 185 meters of the net cables. The nodes should never be placed closer than 5 meters apart. So there are several types of coaxial cable. These are the thick net or the base 5 as mentioned. So it is a coaxial cable used in networks operating at 10 megabits per second with a maximum length of 500 meters. The other one is the thin net or the thin base 2. It is a coaxial cable used in networks operating at 10 megabits per second with a maximum length of 185 meters. The other one is the RJ59. Is most commonly used for cable television in the US. And the RG6 is higher quality cable than RJ59 with more bandwidth and less susceptibility to interference. The other thing is the fiber optic cable. So number 3. What is the fiber optic cable? So it has one or more optical fibers enclosed in a sheath or jacket. Since it is made of glass, fiber optic cable is not affected by EMI or RFI. So this is the example of the fiber optic cable. Again, what is fiber optic cable? It is a type of cable that contains one or more optical fibers that are used to carry light. Fiber optic cables offer significantly higher throughput than copper-based cables, such as coaxial cable or twisted pair cable. Optical fiber may be single-mode or multi-mode. Let's look at the structure of a fiber optic cable. Fiber cable consists of center glass core surrounded by several layers of protected materials. The outer layer is a jacket. The insulating jacket is made of Teflon or PVC. The second layer is buffer, which is used to encapsulate one or more optical fibers, provide protection from physical damage. The layer around the fiber core is a cladding. Cladding is made of glass or plastic shield around the core. The cladding serves as two purposes. 1, it protects the core. 2, the cladding reflects the signal down the fiber. In other words, light travels to the core by constantly bouncing from the cladding. Because the cladding does not absorb any light like mirror, the light can travel great distances. Besides, the light bouncing or reflection from the cladding allows fiber to bang around the corners without affecting the transmission signal. The center core of fiber cable is made of a glass fiber. Light or LED travels through the core. Single-mode optical fiber is designed to carry light with single mode, which means that light wave travels in the same way or in the same pattern, and that gives us a single ray of light. There are some features of single-mode fiber. Single-mode fiber can offer high transfer rates over long distances. The core diameter is very tiny. It's about 9 microns or micrometers. The width of a single human ranges from about 20 to 200 microns or micrometers without a special equipment. We cannot see the core with the naked eye. Laser-generated light travels over one path, and the light does not disperse as a signal travels. Since single-mode fiber can carry signals many miles before repeating, that's why it is better for long distance such as one connection. An internet backbone uses single-mode fiber. If you see a patch cable with yellow color, it is single-mode fiber. Multi-mode optic fiber is mostly used for communication over short distances like within a building or on a campus. Light waves are dispersed into numerous paths or modes as they travel through the cable core. Multi-mode links can be used for data rates up to 100 gigabits per second. So here are some additional features of multi-mode fiber. Multi-mode fiber core has a larger diameter than single-mode fiber. Laser or LED generated light pulses travel at a different angles. It has a greater attenuation than a single-mode fiber. Model distortion is the sole problem of multi-mode. Multi-mode is better for a short distance. As I mentioned a while ago, if you see fiber patch cable with orange color, you know that it is made from multi-mode fiber. Let's look at optical fiber core diameter. Single-mode fiber versus multi-mode fiber. Fiber core size is so tiny that we cannot see it without our special equipment. We use micrometer or micron as a unit. 1 micrometer or micron is 0.000001 meter or 1 millionth of a meter. Single-mode core diameter is about 9 micrometer, and multi-mode fiber core diameter is from 50 micrometers to 62.5 micrometers. The length or size of a typical bacterium is about 1 to 2 micrometers. The diameter of human hair ranges from 20 to 200 micrometers. The size of COVID-19 virus is approximately 0.125 micrometer. These viruses are so tiny, yet they are terribly powerful. So be safe and wash your hands religiously with warm water and soap, or at least for 20 seconds. While I wash my hands, I sing Happy Birthday to you. Happy birthday to you. Happy birthday, dear myself. Happy birthday to you at least twice. Let me summarize the major differences between the multi-mode and single-mode. Single-mode fiber has a smaller core. Laser light travels in the single mode. And the single-mode fiber is good for long distance. While multi-mode fiber uses several different modes when light travels inside the core, light or LED travels in different patterns or modes. That is why it is called multi-mode. It has a modal distortion problem. Multi-mode fiber is good for short distance. It is cheaper than single mode. Okay, activity cable wire grouping. Directions. Complete the diagram of various type of cable wire. So first is twisted pair. Number 1. I'll give you 5 seconds to answer the given activity. Okay, number 1. Okay, number 1 is unshielded twisted pair. How about number 2? Okay, STP or shielded twisted pair. Let's proceed to the coaxial cable. Number 3. Another 5 seconds. Okay, the answer for number 3 is thick net or the 10 base 5. Very good. How about number 4? Okay, thin net rather, or the 10 base 2. That's good. So we will proceed to number 5. Okay, what is the answer? It's RG59. Okay, number 6. The answer is RG6. Okay, we will proceed to number 7. For fiber optic cable. Number 7 is multi-mode. Next is number 8 for fiber optic cable. Again, number 8 is single mode. Next, we will proceed to category of UTP cable. Okay, answer number 9. Okay, another 5 minutes. 5 seconds rather. Okay, number 9 is Cat 3. How about number 10? Okay, so it is Cat 5. Number 11. Okay, nice try. We have Cat 5E. Okay, we will proceed to number 12. Number 12 is... Okay, Cat 6. Okay, very good. Okay, so we'll proceed to the next activity. Activity 2, Match Me. Directions. Match the cable type in column A with their meaning in the column B. So we have here column A and the column B. Okay, so this time I'll give you 10 seconds to answer the activity. Okay, so you may now start. Okay, time's up. So number 1 is... Okay, it's letter D. A type of copper cabling that is used for telephone communications. Okay, number 2, coaxial cable. Okay, it's letter C. A copper cord cable surrounded by a heavy shielding. How about number 3? Fiber optic cable. It's letter E. A glass or plastic conductor that transmits information using light. Okay, number 4. Let's proceed. UTP cable. It's letter A. Cable that has 2 or 4 pairs of wire. Okay, last number. STP cable is no other than letter B. Each pair of wire is wrapped in metallic foil. Okay, very good. Good job. Okay, check time. Number 1. Okay, which of the following type of cable that is used for telephone communications and Ethernet networks? Okay, what letter? It's letter B. Twisted pair. We will proceed to number 2. What type of cable that has a thicker core than single mode cable? Okay, is it letter A, letter B, letter C, or letter D? Okay, the answer is Letter A. It's multi-mode. Okay, number 3. Which of the following is not a coaxial cable type? Okay, what letter? Okay, it's letter D, the Cat 3. Okay, number 4. What type of cable that has 2 or 4 pairs of wires? Okay, and the answer is letter B, unshielded twisted pair, or the UTP. Okay, so next is number 5. What type of UTP cable in which wiring is used for telephone system and Ethernet LAN? Okay, it's letter C, Cat 3. How about number 6? Which of the following, where each of wire is wrapped in metallic foil to better shield the wires from noise? Okay, the answer is it's letter D, STP. Okay, we'll proceed to number 7. It is a coaxial cable used in networks operating at 10 megabits per second with a maximum length of 185 meters. And the answer is it's letter C. Okay, how about number 8? What type of cable which is made of glass or plastic conductor that transmit information using light? Okay, it's letter A, fiber optic. Okay, number 9. It is mostly used for cable television in US. It's letter B, the RG6. Okay, number 10. What type of coaxial cable with more than bandwidth and less susceptibility to interference? Okay, what is the answer? Okay, it's letter C. It's RG6 again. Okay, how about number 11? Which type of cable that has a very thin core? What is the answer? Okay, the answer is letter B, single mode. Next, number 12. Which of the following are examples of twisted pair cable? Okay, so what is the answer? Okay, it's letter C, UTP and the STP. Okay then, so for your performance task, so list down equipments or materials made of cable in your house and identify its type. Okay? So list the materials or equipment and the type of cable. So here are the questions. What are the characteristics of those listed cables? So please state the characteristics. Then cite their advantages and disadvantages. Okay? So for your performance task again, you can send it through our FB Messenger, or you can PM or DM me your answers. compare fiber optic cable with a twisted pair cable. There are many benefits over copper-based twisted pair cable. They can provide extremely high throughput at 10 gigabits per second, very high noise resistance, excellent security, and they are able to carry signals for longer distances. Of course, there are drawbacks. Fiber is more expensive than twisted pair cable. Cabling itself is more expensive. Transmitters and fiber equipment are more expensive, and fiber cable installers are more expensive. So fiber cable also requires special equipment and skills. When we choose cables for our network, we should consider many factors, such as the network size, throughput demand, environment, and budget. But no matter which one we choose, choosing the one that best suits our network demands is an important task for every network expert. Just like choosing priorities in life, we choose to study and learn. So as a student, no matter what circumstances we're facing, especially today that we're facing high cases of COVID-19 or Omicron, but still, education must continue. Thank you very much. I hope you learned something from the lesson. Thank you and congratulations, everyone. Bye.